Hello everyone, thank you for tuning into my video. I decided to try something new and create a series of videos where I live code some computer science topics as a way of practicing my live coding skills, solidifying my understanding of these topics, and practicing my communication skills. Today's topic is linked lists. We can call this linked lists part 1. So let's get started. So what is a linked list? A linked list is a collection of elements. Each element is a node. Linked lists are composed of these nodes and the pointers, the references between these nodes. So each node has a value and a pointer to the next node. A linked list is defined by its head node and composed of the nodes following the head node and references connecting these nodes, known as pointers. So how do we implement a linked list in JavaScript? We can create a class called linked list. This class is given a constructor function, which is used to create instances of the linked list class. So we give the linked list a head node, which we initialize as null. And then we create a second class for the list nodes. A list node is initialized by its value. And is also given a pointer to the next node, which is null in initialization. So in order to create a linked list, we need to create a append function. Where we give the append function a value for the new node. So what is append? The append is adding a new node to the tail of the linked list. So as shown here, we have a linked list composed of nodes of value 2, 5, and 3. And the node with value 6 is appended to the tail of the linked list. So we can make a new instance of the list node with the value that we want to add. An edge case that we need to consider is what if the linked list does not have a head node? So we check for this. If the linked list does not have a head node, then we set the head of the linked list to the new node, and we return the head of the linked list. So as you can see here, that linked list is only defined by its head, and the list nodes define the relationship between the remaining nodes. So we can test this function. So let's make a new list, list 1. And then we can append a value to this list. And then we can console log this list. Let's test it out. Unexpected token. Let's see, where did we go wrong? Oh, I see. So I didn't create the function correctly. New node. Oh, I called it node. We can call it new node. Oops. So as you can see here, we have a linked list with the added node as the head. So we can make a function to print out the linked list in a easier to see format. So we can make a toArray function. That takes in the list. So we can make an output array. And then we can set a node equal to the head. And then what we're doing is stepping through the linked list and pushing the values of each node into the output. And then we can return the output. So let's test this out. So we can take the list 1, and call toArray on this list. And what we get is an output with the value of 2 in the array. So now, how would we append to a linked list that has a head node, or multiple nodes for that matter? So the linked list only has a pointer to the head node. It doesn't have a pointer to the tail node. So what we can do is we can make a node, or we can make a tail variable and set it equal to the head. And then what we can do is step through the linked list until we reach the tail node. And then once we reach the tail node, then we can set the reference of the tail node to reference the new node. And then this effectively adds the new node to the end of the linked list. So we can say while tail.next is not equal null. So while there is a node, while the tail is not the tail effectively, and we step through the linked list. And then once we reach the tail, when the tail.next is null, which looking at this diagram, if the tail is 3, if the tail is a node with the value of 3, before the node with a value of 6 is appended to the linked list, the reference of 3, or 3 does not have a next node, so we know that we reached the tail. So we set tail.next to equal the new node, and then we return the head. So let's test this out. So if we append the value of 5 to the linked list, and we should see that the new node is appended to the value, to the linked list. And we can similarly do three and 6. Check it out. Alright, so how do we prepend to a linked list? So prepending is adding a node to the beginning of the linked list. Let's give it a shot. So we can define a method prepend that takes in a value. And then we can create a new node with the value. So there's a similar line of thinking. So if there's no head to the linked list, then we set the linked list head to the new node, and then we return the head. So let's think about how we would do this prepending if there were multiple nodes. So what we need to do is set the new node's pointer to the new head, to the old head node. And then once we set up the pointer, then we reassign the head of the node to the new node. So this is a similar line of thinking when manipulating linked lists that I found, is that you set up the references between the nodes, and then you reassign the node whenever you're manipulating the nodes of a linked list. So the new node's pointer is set to the head of the node, and then we set the head to reference. So the new head node becomes the new node, and then we return the head. So let's try this out. So we can do a list one.prepend. We can prepend the value of 4. And there you go. The value of 4 is prepended to the current linked list. So that's all I wanted to go through for this first video. We prepended, we initialized the linked list, or we created a class for the linked list, we created a class for the nodes, we create a function to append nodes to the linked list. We created a function to prepend a node to a linked list. And then we created a function that puts the values of the linked list into an array to be easily read. Thank you for watching my video.